Welcome to this step-by-step tutorial for a Blynk IoT two-wheel drive car with an ESP32-S microcontroller. This is a car we can control through a Blynk IoT app via smartphone, whether an iPhone, Android or otherwise. So this is the Fritzing diagram for the car. You can see we have an ESP32-S microcontroller. We have two wires connected to pin number 4 and pin number 5, which will connect to the L298N motor driver on in 1 and in 2, and that will power up and control this motor at the top, whereas digital pin 12 and 13 are connected to in 3 and in 4, which will control the motor at the bottom, just like that. Something I have to mention. DC motors do require a voltage higher than 5 volts if you want this to run a lot faster. If you want a faster car at the fastest speed, you're going to have to up the voltage. But you see, the thing is, like with this ESP32S, you're not supposed to use a voltage greater than 5 volts. Otherwise, you're going to end up frying this board. So you want to be able to have a high voltage for the motors to make it fast. At the same time, you want to have a voltage that's not going to fry your board. So we can do that using the L298N. So what happens is, like the 7.4 volts from the battery will go directly into this part, and this, see where it says 12 volts, that will go in there, and that will help to power the respective motors at the maximum speed. But then coming out, it has a voltage regulator, which will convert that to a 5 volt. And then that will go all the way back down into the V-in, which is 5 volt, and that will power up the board and it will not fry it. So, and then we connect the negative. And we have a flip toggle switch here, which we can use to power up this whole device, okay, without having to keep removing the battery each time. So that just makes it better. And we will glue that to the aluminium chassis also. So in order to build the actual car, we're going to need the following components. We need one ESP32S microcontroller, one half breadboard, one aluminium two-wheel drive car chassis. This is very similar to the one that they use for the MBOT from MakeBlock. And you'll also need 10 30mm Phillips flathead screws with the 8mm head with the respective nut. And you need 6 of these to hold the battery. We'll get to that soon. And you're going to need 4 of these to connect these two motors, which are two DC 3 to 6 volt TT motors with the respective wires. If you haven't got the wires soldered, you have to do that, but these are pre-soldered. Okay, we also have, that comes with the chassis, two 65mm car wheels. These are the white ones. You can get some yellow ones. They're also quite common. Just use whichever one works for you, it's fine. You'll also need one mini caster wheel with the respective screws, which is this one here. This is the mini caster wheel that comes with MBOTs from MakeBlock. Feel free to use whichever caster that you choose, but I tend to like this one quite a lot because it works on various surfaces. Okay, you also need one L298N motor driver, which is this one. And you're going to also need two 30mm plus 6mm hexagonal pillar mount with the screws. You're going to need that because you want to elevate this. Again, you'll see in a moment how we use these. Right, this is going to lift it up so that we can fit the breadboard underneath on top of the aluminium chassis. You'll also need 3 10mm male-to-male jump wires, 3 20mm male-to-male jump wires, and 4 10mm male-to-female jump wires. Specifically, these are for connecting the L298N to the ESP32S microcontroller via the breadboard. What else do we need? We also need, oh yes, in order for the battery to work, we're going to need one 2.1 times 5.5mm female DC power adapter plug, which looks like this. And you'll also need one toggle flip switch. So the flip switch is what we use if we want to turn on the car on, well, we want the car to turn on and off without having to remove the battery every time. So we need to have a switch. We also want, for the battery, one 7.4 volt lithium ion battery. This one has a barrow wire male connector on it, so we can connect it to this. We also want, last but not least, one ball of blue tack. This is going to be used to secure the battery in place. Again, you'll see in a moment. In terms of tools, you're going to need a wire stripper. You're going to need a glue gun. All right, that's for sticking the switch in place, as well as this barrel connector. You're also going to need a soldering iron with some solder, because you're going to have to solder some wires to the flip switch. And you'll also need a couple of screwdrivers, right, for your screws and your nuts. And this one has a hex, sort of like an Allen wrench. So some of the screws may require an Allen wrench, but otherwise you can just use the normal Phillips head. Right, this one's actually detachable, so you can swap it around. All right, just use whatever works for your respective components. So there we go. So first thing we're going to do is take the ESP32-S microcontroller, remove the protective styrofoam from the bottom, and insert it into the breadboard. So I'm going to just like that, just push it in like that. Okay. Now what we'll do is we're going to take the aluminium chassis and we're going to stick this onto the bottom. Now, fortunately, these breadboards do have a sticky back bottom, so we just remove that and we're going to stick it there. So we take this and just put it there. Okay, so just like that. So now it's holding its position. Okay, good. So let's get these motors plugged in. So we'll take this one and grab the chassis, and you want to make sure that this bit that's popping out has to be sticking out of here like that. There we go. Yeah, that's what you want. Okay, and it clicks in place, and then you just want to get the long screw and just put it in like that and like that. Right, and then get your nut. We'll get this nut and then just screw it on. Just use your fingers and then get a screwdriver and do the rest. So that's a Phillips head screwdriver. So do the same with this one. Just screw it in. And let's grab the screwdriver, so this one, and just screw it in. Right, that's one. We'll do the next one. So exactly the same thing, but just on the other side. So that's it, we got both motors are in, and we want these two wires to pop up here because we need to put it into the motor driver. So let's just thread the wires up. Yeah, there's a couple of holes here that we could use, so we'll just put that up in there, and we'll do the same with this one. So just thread that. Right, you want it to be popping up like this, okay, just like that, and we want to do it for the other set of wires for the other motor. So let's do that now. There we go. Now for this part, we want to put the L298N motor driver over here. And we need to use these pillar mounts, and the reason why is we don't want this to be literally sitting on this part of the breadboard, because you never know, in the future we might want to use this part of the breadboard to add LEDs, push buttons and so forth, but that will be for another day, hopefully. So we want this to be raised up like this, and we can use the pillar mounts in order to get that done. What you need to do is you need to find the right holes to align with these two, so it will fit like that. Let me show you. So take a pillar mount and just screw it, right, and take the other one. Make sure you put it into the right holes. All right, once that's in, then take this and it should align. Yep, it aligns perfectly. So now get your screw and put the screw on one end, or one corner more like, and put the other screw into the other corner. It's that front part. Hang on. All right, good. Now get your Phillips head screwdriver and just screw this into the pillar mount, just like that. Okay, don't have to do it too tight, but there we go. So what we have is we have the motor driver at the top, we have the breadboard, and we've got all the space that we could use in the future, and just like that, and it holds. Now we'll add the caster, and we'll do the wheels much later on, because we still need to add the program and stuff, and we just want to make sure that this doesn't drive all around the place, so we have to keep the wheels off. But we can do the caster since it's not powered by a motor. Right, so this is the caster wheel, right? And I happen to like this wheel quite a lot because it works on more surfaces compared to other casters. Now, some of you may have ordered some of these aluminium chassis that come with motors and so forth, and you may have encountered a caster that looks like this. It's just a silver ball inside this white contraption. And if you take a look at the two, I find that when you try to run this car along certain carpets in certain households, this seems to have problems with certain carpets, whereas this one seems to work quite well. So all in all, I mean, if you want to use this one that comes bundled with your aluminium chassis, then, by all means, but I prefer this one. So, but like I say, feel free to use whatever works for you, but I like this one. Anyway, let's keep going. So these are hex screws. You can find other types of screws. I find that the hex screws are easier to fit in. You don't have these long screws at the bottom, and you don't have to fiddle for the nut underneath. So this is better. And I know some people are saying, well, I should have put this on before I put the motor driver on. But anyway, I'm not going to go back now and fix it. So get my screws. Well, just do it like that. It's fine. I'll just get my, this is like a hex screw. Again, you can use any kinds of screws as long as it fits. As long as it keeps the caster in place, it's totally fine. And right now, because of this, I'm going to use a hex wrench, a hex screwdriver. This one is modular. You can replace it with other types of heads. So this is a, what do you call it, a hex head? Or an Allen wrench, although Allen wrench is more like an L-shaped hexagon key. But anyway, let's move on. These are quite common with M-bots. The hex screws are very common with M-bots. Right, yeah, you want to make sure that the caster wheel is facing that way. Yeah, you don't want it to be facing that way. So anyway, yeah, there has to be a space between the caster wheel and the top. So like here, there's a space there. And there's your caster wheel. Of course, we will have the 65mm wheels later. Okay, so we will do that later. Now we're going to have a look at the battery. So this is a 7.4 volt lithium-ion battery, rechargeable, and I've fitted a male barrel wire connector, so it fits really well with this one. Now, what I'd like to be able to do is have this battery on the car. Of course, space is a bit restricted, and what I would like to have here, I'm not going to put the battery there because it's a little big, and also we want to reserve this space for the flip switch, and we also want the barrel connector, and then we want to have some space to put these two together. And also we don't want to have the battery here, because what happens is, because there'll be so much weight on the back, every time the car moves, it's going to do these wheelies. So every time it moves, it's going to, move up like this, because there's so much weight at the bottom. We're trying to distribute. We want to distribute the weight a little more evenly alongside the car. So we decided to put the battery on the front. Now, the question is, how do we hold the battery in place? That is the ultimate question. Now we have the ultimate answer. What we do is we're going to create like a surface where we can sit the battery like this, and we're going to use a blob of blue tack to hold it in place, in order to create the space so that the battery doesn't jiggle like this. Right. If I show you a finished car, so this is a car that's already been finished, so you can sort of see what we have here. So we've got 3 of the screws, right, and the nuts hold them in place, and the lithium ion battery is right there, and we've got a blob of blue tack that fills up the remaining space so the battery doesn't jiggle, right, and it's got the 2 wheels, but we'll get to that later. You can see where we've put the barrel connectors, and there's a flip switch there, which we'll get to later, and all these connections we'll sort out in a moment. Right, so anyway, so what we're going to do is we're going to put these screws. So just put them in so you know exactly where they go, so you don't put them in the wrong place. So like that, see? And then do it exactly for the other side. They've got to be parallel with one another. Right, so we've got that, and we want to use the nuts to, let's put the battery aside, we want to use the nuts to fasten these in place. So let's do that. And there we go. Yeah. Now let's show you the battery. So if we take this battery and we just, let's insert it so we can put it there. It will, just find a way. It will fit snugly in there, but you're going to need to put some blue tack in there as well. And there would be a barrel wire connector, which will be right here. And we just plug that in, but we'll worry about this one slightly later. Now we need that blob of blue tack. So we take this, and you don't need to use the whole lot. Just use as much as it takes to fill in the gap. So, okay, so just take that. As I've said, there's many ways to do this. This is just one way that works. And yeah, just sit that like that. And I think that'll do. Yep, I think that will do. Great. So let's go to the next part. Now we're going to get the motors into the motor driver. So we need to put these 2 wires into here and these 2 wires in here. So get your Phillips head screwdriver, and if it is tight, you want to make it loose. And then you simply just plug these in. So we're going to put the red one on the left side and the black one on the right. So you just insert that in. Then get your screwdriver and tighten it, just screw it down. Right, just tug on it a bit, just make sure it doesn't fall out. Okay, that's good. Now, do the other side, screw that down. All right, here we go. Now we're going to plug up some wires, some power wires to these bits here. And we're also going to add a flip switch down at the bottom, and we're going to have a barrel wire so that we provide power to this device. And we're also going to plug each of the respective motors using the in1 to in4 into the ESP32-S. And we're also going to plug this to the power as well. Right, let's have a look at the switch. So there is the switch, and let's get this all wired up. So take our flip switch and let's just flip it on the other side. We need to plug the red wires to those two contact points. Right, so we take the long and the short wire. We'll take a wire stripper and just cut the ends off both sides of the wire. We just want a bare wire, that's all. So now take the long wire and do exactly the same thing, just cut the wire. So you want to take the ends off. Right, just like that. Okay, and now we are going to strip the wire. So take a wire, take the wire stripper and use the strip part at the top and strip the wire. Right, and do it for both ends. So both wires, strip it and put that down, clear all the debris. Same thing with the short wire, just strip it, because you're going to put this into your L298N, and we're also going to put it into the flip switch as well. So we do that, and just make sure that there's enough wire sticking out. Right. Now we need to solder the wire to the flip switch. So I'm using this apparatus here to do it. So I take one end of the wire, I plug it in, well I affix it. I'm going to use a screwdriver just to kind of bring it around. So, right, so it's a little fiddly here. So, and then take the other wire and do it for the other point. Just like that. Right, once you've done that, get your solder, get your soldering iron. Let's just prepare that, and let's get our piece of solder, and we need to solder the wire to the switch contact point. Right, so here we go. I admit my soldering skills are not that great, but I'm sure you can do a whole lot better, but just bear with me. Yeah, I'm still practicing the whole soldering thing. I admit I'm anything but perfect. So solder the both bits. That soldering iron really has a lot of mileage. And there we go. There's our switch with the wires soldered on. So there's our flip switch with the wires that have just been soldered. And we're going to attach it to the female barrel wire connector. You'll notice we have a hot glue gun on the right hand side because we're going to stick this and stick this over there. Okay, so we're going to prepare that for the battery, which we'll use a little later. So anyway, we also need to connect these wires to the respective parts. So one of them is going to go into the female barrel connector, and this part's going to connect to the 12 volt plus section of the L298N. So anyway, let's work on this. So we're going to take this and we're going to plug it into the positive section. So it's down here. So if necessary, get your Phillips head screwdriver and just plug that in. Make sure this is stripped properly. We did strip it earlier, so I'm going to plug this in, get this inside, and then just screw it down. The negative part, we will sort that out later. Now for this part has to go into the 12 volt bit, but we'll do that later. Let's get the glue gun sorted. So what we would like to do is take this, and we want to apply a bit of glue there. So let's take this off the blue tack, and let's just apply a dab of glue here. So just apply that. Okay. And then just grab your switch and just put it down accordingly. Just glue it securely like that. All right, let's see. Hopefully that will stay. If not, we'll have to add more glue later. Right now, the next part is we want to... Now, for the female barrel wire connector, I think it might be better if we get the black wire. Get your black male-to-male jump wire, and you want the small one as well. So you want to... So what we're going to do, we're going to insert 2 of these. We need to strip both of these bits, and it needs to go into the middle part, the negative, so it needs to go in there, this middle part there. So get your wire stripper, and we're going to cut the wire. Maybe we'll just do one at a time, so let's do that. So cut this end and cut the other end. Okay, and then get rid of this. Now, because this has to go into the barrel wire connector, we also want to strip this end. This end we have to keep because this has to go into the breadboard, because it has to connect to the microcontroller. So this remains intact, but we have to strip both ends of the longer black wire. So there we go. Now we're going to strip. So we'll strip the wire. And strip this also. Now, what we're going to do, since we need to get both of these wires connected to the middle part, we have to put these 2 together. So take these 2 bits and just twist them together so they stay together as much as possible. And then take that, and you might need to unscrew that, but I think it's unscrewed already. So if we just put that in there and screw it down. Right, we'll connect this wire in just a moment. So we also want, now we want to thread this wire so it reaches the barrel connector. And we'll just twist this a bit, and then take this, just shove it in there, screw it down. Oh, sorry, once it's in, screw it down. Good. All right, and now we want to take, well, what we'll do is, I think we'll glue that first, and then we'll put that in the 12-volt section. So let's get the glue gun, and we want to apply some glue down at the bottom. Be careful with this. So just a blob. Okay. And then just sit that down like that. So you've got to be quite careful. Yeah, you don't want this to be going over the edge because you don't want it to be clashing with the wheel that we're going to put on later. And notice there's a bit of excess glue on the side. I'll clear that up with my fingers later. So, if you make a complete mess of it, you can remove it and just reapply the glue again and start over. It's absolutely fine. So I've done a few glue jobs and so forth, and I've messed up a few times, so I'm quite used to it by now. So anyway, yeah, that might just do. You can tuck in the wire a bit, and yeah, and then this would just connect in there, but we're not going to do that yet. Now, for this part, we are going to connect this to the ESP32-S microcontroller. So now let me just check. So this has to connect to the negative rail. Oh, by the way, if you take a look at this pinout diagram for the ESP32-S, so we're going to connect the ground. The ground is here. See where it says the number 38? The ground is right there. So by and large, if you take a look here, the ground should be there. The reason why I use the pinout diagram is because the pin numbers are actually not on the top of the board. They're at the bottom. But since you can't see the bottom, we have to use the pinout diagram. And now luckily it's just there. So we could just connect it to there. So yes, you're going to have to use the pinout diagram. Otherwise you won't know what the pin numbers are. So there we go. So that's connected to the negative, or to the ground actually. Right, let's rotate this. Now for this part, we want to connect this to the 12 volt section of the L298N. So the wire is actually a little longer than I thought, so just wrap this around and just take that. And all you have to do is just take this and put it into there. So I'm going to jam this in there and put it in. So hang on, right, and once it's in, screw it down. We'll do the 5 volt section in just a moment. As a matter of fact, we're going to do that next. So that's the 12 volt plus, the ground, and that's the 5 volt. And we need this to power up this board without it frying. So we're going to need another wire. So hang on just a moment. We're going to need another wire. So grab another 20mm male to male, and we just do the same thing. We need to cut and strip one end so we can plug it in there, and then the other end goes into the breadboard to power up this microcontroller. So get your wire stripper and use the cutting part to cut one end of the wire, get rid of the debris, and strip the wire. Right, and then we'll take this and we'll just put it into the 5 volt section and screw it down. Yeah, the wire's a little long, but better long than short, but okay. Now, take this, and again, looking at the pinout diagram, so we want to plug it into the V in 5 volt, which should be like, if we just turn it around, okay, it should be there. Oh, hang on, sorry, just make sure to thread the wire all the way through. Okay, so it should be there, where it says number 1 on the breadboard. And there we go. Oh, I do understand with the Fritzing diagram, I actually said that you can actually put this wire onto the negative rail and then simply just take this and do that. Well, either way, it doesn't really matter. I mean, but both of them work. But just for the sake of consistency, I'm just going to follow what I've done on the Fritzing diagram. So if it works, it works. So there we go. Just like that. Now we want to make sure that this whole thing will power up. Now, as a safety precaution, please make sure the switch is off. So right now, so that's on, and that's off. Just make sure it's off. We're going to take the battery and plug it into the barrel wire connector, the female barrel wire connector. And okay, just like that. It fits quite snugly. And all you have to do is just flip that switch and hopefully it will turn on. Yep, it turns on right there. So there, and the motor driver will also light up, and the ESP32-S will light up. Great, now we can turn that off. Now we're going to connect the L298N motor driver to the microcontroller, basically have the motors connected to the board. So in order to do that, we need to connect these male to female jump wires to each of the pins. So in 1, in 2, in 3, and in 4. So if you look at the Fritzing diagram that I showed you earlier, I put the orange onto in 1, the yellow onto in 2. You can use any colors you want. I'm just using this because I've been used to it for a long time. In 3 for the green wire and in 4 for the blue wire. Right. So let's get this connected to the microcontroller. So in 1, the orange goes to GPIO4. We're going to loop this over. So that goes there. Oh, just tuck that down. Yep, that's good. Okay, so that goes at number 7 on the breadboard. And the the yellow wire will connect to this part. Okay. Yep, just like that. We've got in 3 and in 4. So in 3 will connect to GPIO12. So GPIO12, just like that. Right, and this one connects to number 5, so there, just like that. So now we're going to use Blynk.cloud because we would like to add the device to the Blynk cloud, as well as to later create the user interface for the smartphone, as well as maybe one for the web. So use your email address to log in to Blynk.cloud. Oh, excuse me. And what we have to do is create a new template. And we're going to call this ESP32-S IoT car. Hardware is ESP32, connection is Wi-Fi, press done. And we're going to add some data streams. Now, data streams, we need to specify the pins that we're going to be using for the car that's going to interface with the Blynk.cloud. So in this case, we're going to interface with the pins on the L298N motor driver. That's in 1, in 2, in 3, and in 4. Okay, so let's put in 1. That's pin 4. So what we put on the Fritzing diagram before. So that's in 1, and we need one for in 2, in 3, and in 4. Now we can duplicate this and just put in 2, and that would be pin 5, and in 3 would be pin 12 and pin 13. So pin 12 and pin 13, and the pin mode is output. And let's just keep going. Oh, hang on. Sorry, I'm supposed to duplicate that. So it should be in 4 and pin 13. Now we've got that. We would also like to make some virtual pins, because what we would like to be able to do, well, in order to make our car move, it all depends on which of the in pins we send a signal to. So for example, I'm just throwing a random example. It might not be completely accurate, but just bear with me. Let's say, for example, if you send a signal to in 1 and in 2, it may make the car go forward. If you send a signal to in 3 and in 4, and these are both 0, it will make the car move backwards. Different combinations will make the motors turn left or make the motors turn right. And in order for that to happen, you've got to create virtual pin, which will call some inputs to the in 1 all the way to in 4. Anyway, let's just work on that. So, new data stream. Hopefully it will make sense as we progress further throughout this video. So we need to make a virtual pin, and for the virtual pin, we'll just call it, I think just integer v1 is good enough. And we're going to use v1, right? Just keep everything the way it is. That's absolutely fine. So we've got integer v1. We can duplicate this and just do the same. So we need 4 of these. So one of them is going to be for move forward, the other is going to be move backwards, and the others turn left and turn right. Oh, actually, why don't we just do it like that? Right, okay. So let's go to new data stream and let's create a virtual pin. So let's say for this virtual pin, this is going to be for move forward, and we'll set that to virtual pin 1, and let's press create, and we'll duplicate that, and we want one for move backward, and that will be virtual pin 2, and then we'll also want virtual pin 3 for turn left and turn right. So virtual pin 1, 2, 3, and 4. There we go, that's what we have. Okay, then we got the right labels, so it makes a lot more sense. And once that's done, you press save. And for web dashboard, although we're going to be using the smartphone to control, we're not going to be using a web dashboard. This is just for debugging purposes. So if I go to edit, so I'm going to add 4 switches. I could just take one and duplicate it, but that's fine. So I'll just take this and just put it in the right place. You can resize it if need be. And this one is going to activate in 1. Again, it's for debugging purposes. So that's in 1. And this will be for in 2. All right, just keep going. In 3 and, and in 4. Just like that. All right, once that's done, click save. All right, and then we want to go to press the search. We want to press new device. So we're going to create a new device based on this template. So we go to new device. From template, we're going to choose that. Yep, ESP32-S, just keep the same name, it's absolutely fine. And you're going to need the template ID, device name, and the auth token for the code, right? So you're going to need that for the code in just a moment. So now we've loaded up the Blynk app on the iPhone, or you can use Android or whatever you happen to have. We're going to log in, and we're going to put in our email address and password. So we need to log in. And once we've logged in, you'll see ESP32-S IoT car. It's there, but it's offline. We still need to upload the code to the microcontroller, but we'll do that later. Now, I've just clicked on. We're going to make an interface. So we're going to add some buttons. So where it says controller, press button. And this is going to be for, let's say, in 1. This is for debugging purposes, and we want the button to remain on, so we use switch. And, hang on. Oh, let's put the label as in 1. And let me just check, make sure that's okay. Right, that's fine. Now let's add some more buttons. So this will be in 2, a switch, exactly the same thing except you're doing it for in2 data stream. Okay, and another button for in 3, and you want another one for in 4. So let's work on that. Make sure it's a switch. And so in 4. Right, and there we go. So that's how it would look. Okay, so you push a button, it stays on, just like that. You can arrange the buttons somewhat, so you could maybe have in 1 and in 2 at the top and in 3 and in 4 at the bottom. Just drag and drop the buttons any way you see fit. I'm going to stretch out the buttons slightly, so maybe like that. Okay, just like that. And then, so you've got a bit more room for your fingers. So let's just take this and stretch it. Yep, there we go, just like that. You're also going to want to create a controller, so up, down, left, and right. So what we do is, hang on. So again, just a tap on the screen. So again, press button, and this is going to be for up. So this will be a push button. It will not be a switch. So you want to be able to, let's say, see that the bit at the bottom that says up. If I hold it down and then let go, hold it down, let go, like that. Yeah, that's what you want. So yeah, anyway, let's keep going. So you got one for up, and then you want a button for down. Oh, hang on. Make sure you choose the data stream. It has to be moved backwards, and the up should be moved forward. So make sure you choose the data stream. Okay, so up, down, and then you want for left and for right. We'll call it turn left and turn right. Okay. And turn left, turn right. Right, let's we can resize the buttons somewhat. So just resize a bit. It's entirely up to you if you want to resize it. I just prefer to have the buttons a certain size where certain finger sizes don't have problems pushing the buttons. So try to make them slightly big, but not so big it takes up so much of the space. You want it to be quite reasonable. So there we go. That's how I do it. You can also change the color of the buttons if you so choose. So let's say you could have like red for the button. Again, it's entirely up to you. Could have different colors for the turn left and turn right. So maybe a gray color for turn left and turn right. Right, just like that. So up, down, left, right, up, down, left, and right. So there we go. There's the smartphone app. Let's move on. So now we're going to work on the code in order to get our microcontroller on the car connected to Blynk or Blynk IoT. We're going to have this all connected together. So we need to work on the code, and for intents and purposes, we are using Arduino IDE version 2.0.3 as of the date of this video. So you'll notice at the top, we've got the template ID, the device name, and the auth token. So we need this information from the blynk.cloud so we can connect our microcontroller to the blynk.cloud or the Blynk cloud. So if I put the two windows side by side, you can see, right, we've got this. We need to get all this transferred over to here. So we can simply just copy it to the clipboard and just paste it on top, just like that. Easy. And down at the bottom, right, you want to put in your Wi-Fi credentials. So I'm going to do that now. And just to kind of clarify some of the code. So if you send an input signal to in2 and in4, it will make the car move forward. Actually, it's not really move up, it's move forward. And move down should be move backwards. I'm just going to correct this. And this code will be available in the description of the YouTube video, right? Or you can just message me and I'll send it to you. So move forward, in2 and in4, if that's on, it will move the motors forward. In1 and in3, it will just be reverse, move it backwards. In2 and in3, turn left. In1 and in4, turn right. So different combinations of motors, different combinations of in1 to in4 will have different effects on the motors and thus the movement of the car. Right, hang on, moving down a bit. So we're going to connect to blynk.cloud when we load up the microcontroller. Normally the port for Blynk.cloud would be 8.0, but some places port 80 is blocked, so you can use, especially in certain schools where port 80 is not open, so you can use 8080 and it should work for most, if not all places. Anyway, just use whatever works for you. So that's the code, and I'm just going to save that. Right, and now we need to get our microcontroller connected to the computer so we can upload the code. So let's do that. So micro USB wire, just connect one end to the microcontroller on the back and connect this end to your computer. And yeah, it should light up, that way you know that it's connected. We're just about ready to upload this code, so we need to make sure that in Arduino IDE we have the right board selected. So go to Tools, make sure it's ESP32 and it's Node MCU 32S. Make sure the port is selected. If you're using Windows, it will be COM1, COM2, whatever COM port you have. So yep, the serial port is selected. And once it's done, you hit the upload button. You may also need, because this is an ESP32 board, you may need to press the reset button to put the board in download mode so that we will flash the code appropriately. Oh, I've just realized there's one bit of the code I've forgotten to put in. I need to specify that in1, in2, in3, and in4 are output. So I need to go down here. This will all be in the code, it'll all be ready to download, so you don't need to do this because I'm going to do it for you. So we need to specify, so pinMode, so in1 is output, okay, and we're going to do the same for all the other ones. So I just duplicate that, in2, in3, and in4. Right, so there we go. That way we're not going to have any trouble when we turn on the car, so it'll all be ready to go. So now we're ready to upload. So let's upload. Don't forget about the download mode. So you might need to hold the button on the microcontroller. Right, if you hear the motor, don't worry about it. It's fine. And that's it. We're done. Let's move on. Oh, by the way, I have to apologize. I've just realized that this yellow wire for in2 is actually plugged into the wrong pin. It should be pin 5. Pin 5 is actually the one to the left, so sorry about that. Now, if we plug that in there, there we go. So I apologize about that. So I've got my car here, and we'll put the wheels on in just a moment. We're going to turn it on. So on the back, just flip the switch. Okay, there we go. And I'll just put that down for a sec. You'll notice that I have a screen here. This is not a screen recording. This is just a camera filming the monitor. So because I want to put the car in the picture. So what I'm going to do is I'm going to demonstrate this whole thing about sending signals to different in pins. So let me show you. We've got the Blynk.cloud here. If we go to my device, which is the ESP32-S IoT car, if we just click on that one, you notice we've got all these buttons here. So what I've decided to do, maybe if we just move this down, I'm going to just adjust my camera in just a moment. Sorry, hang on just a moment. Now, if I just bring my camera down slightly, like that, and if I zoom the screen in a bit so you can see it a lot clearer, right? This is a good demonstration of what happens when we send the right input signals to the ESP32, sorry, the L298N motor driver. Okay, so you can see in1, in2, in3, and in4. Okay, now there's my car, and if I send a signal to in1, right, you'll notice that this will go clockwise, motor will go clockwise. If I turn it off, it turns off. If I send a signal to in2, it will turn that anti-clockwise. Right, so similarly with in3, if I turn it around, it will send, okay, that will go anti-clockwise and clockwise, right? So if we wanted this to go forward, we can just put into and in 4. Oh no, sorry, my mistake. That actually goes backwards. Now, why don't we put the wheels on? Let's put some wheels on. So there we go, 65mm wheels. Let's plug it in or insert it in. So this is the final part. We will test out the smartphone app in just a moment. Okay, the smartphone app is ready. So this is connected to the Blynk cloud, because we know that because we've just tested this. Now, just so this doesn't fly off the table, if I just, so in 1, okay, it will just go in a circle like that. Okay, let's take this off. Now let's do in 2. Whoop. In 2, similar thing. Sorry, we need to clear a bit of space, so if I could just bring this, no, I think that's fine. All right, so if so in 1 and in 3, if I put those on, it will move the car forward. It's pretty fast. If I send a signal to in 2 and in 4, moves the car backwards. See? So if I want this thing to turn, but I want both motors to help with the turning, so let's say in 2 and in 3, makes the car turn right. And of course, if I send a signal to in 1 and in 4, it turns the other way, turns left. Oop. There you go. So that justifies the whole significance of sending signals to these ins. So it manipulates the direction of the motors, clockwise or anti-clockwise. All right, let's give this a try with the smartphone. So, right, we've got the Blynk app. We're using the Android phone here. So Blynk app, ESP32-S IoT car, and we use the controls up, down, turn left, and turn right. I'm being a bit cautious because I don't want this to fall off the table. So up, down, turn left, turn right, and then forwards and backwards. Sorry, my thumb's a bit dry, so it's not very good. I have to also make a confession as well. I did previously test this, but I wasn't filming with my camera. But you'll have to be quite cautious because, well, when I pressed up or move forward, I actually realized this was moving backwards, and when I pressed down, it was moving forward. So, and the reason for that is because these wires were actually in the wrong position. So if you're doing the test, you're going up and down, forwards, backwards, and you find that it's moving in reverse in the opposite direction, all you have to do is just swap these wires for the motor. Just swap them the other way. So do the same for there. Okay, so anyway, it's always good to have a test because something's bound to go wrong. So anyway, so forwards, backwards, turn left, and turn right. And it's quite fast as well. So there we go. So there we have it, you guys. That's the ESP32-S IoT car using Blynk 2.0 or Blynk IoT using a smartphone, Android or iPhone. So there you have it, guys. So thank you so much for watching, and we'll see you again soon for more tutorials. Any problems, any questions, please message me. Leave a comment. Thank you so much. We'll see you soon, and goodbye. Thank you.